Yeah,
Uh, sure. I guess you have not shared yesterday's PPTs with us.
PPT already given, na?
It's given, no.
It's
It
given
is given in the
in
Google
the Google
Classroom.
Classroom.
Uh, okay, sir. Okay, I shall check.
Please add in the Google Classroom. It was
Yes,
there.
sir. Yes. Thank you. Thank you.
Okay, sir. Anyone from Vizag? Today there is an incident happening in Vizag.
वैसे तो देखना ये लेट सी लगी. वेट कर दे.
We will start within the 2 minutes. Before I start the next session, one two questions from everyone. I think all of you know safe. And one question is that how many colleges started? From your college is started or not? Madam's college is already started.
Yes, sir.
I know. Any others?
I was from
In Karnataka.
Yeah. Karnataka, all the colleges is started.
Yes, sir.
What
Yes, sir.
about Tamil Nadu?
Sir.
Yeah, sir. Tell me.
Hello.
Yeah, sir. Tell me.
Sir, from Coimbatore Institute of Engineering and Technology.
Yeah.
Our college not started, sir.
Not started. Wow, good. So you are now safe in your home. Good. And college from the Gujarat, Punjab. What about the Goya College of Engineering? It started?
Sir, it has started before 1 month, sir. Almost 15 days.
From where, sir?
Gaya College of Engineering, Gaya, sir.
1 month before? 15 days
Yeah,
before?
21st, sir.
Wow. So it's a
Actually,
hectic. How you are, you are staying in the campus or you are outside from the campus?
Some people are Delhi, and there is no department order also. Sir.
That's I know.
He's playing with the life, sir.
Yeah. Because till now most of the colleges are not open.
In Gaya, in Bihar also, sir, only 2 or 3 colleges open.
Okay.
Very bad situations.
What about the VVM college in Gujarat? Sir, what about the BVM college? It started or not? Maybe network issue. So let's start. And before I start, you have any kind of queries from the previous day? You can ask, no issues.
Sudipta, sir, I just checked my email and I haven't got any invitation for your Google form.
Yeah, sir, already sent to you. Otherwise, Pankaj sir, you have the code, na?
Yes, sir. I have the code and I had
And
invited all the participants.
you given the
sir,
code in a message, so everyone
yeah,
can get it.
I had given the code in everybody's email. So please, sir, check emails once. And
Okay,
if
forget.
okay, I will share the code here also. Okay, no
Yes,
problem at
yes,
all.
that's
I
an
will
Sir,
I will share
sir,
the code here also. Okay, no
Okay.
problem.
sir, I got the code regarding email, but how to go on to Google form?
Just join, and go with a Google Classroom, so you will be get it. No issue. Everything there is uploaded.
There is no joining link to join Google Classroom.
Sir, if you have a Gmail ID,
Yeah.
so you just go to Gmail ID and go to the Google
Okay.
Classroom, and there is
Okay.
options. You given the code, so you will be automatically join.
Okay, sir. I'll try.
you try. If not possible, then tell me tomorrow. I will be, see how it is possible.
Yes, sir. Sure, sure.
Okay, okay, sir.
Thank you, thank you.
Okay, sir. And I, Pankaj sir, can you share with whatever the yesterday video? You share the link over here in a message.
Okay, no problem, no
So that
problem,
will
sir,
be
no
that will be the
problem.
best idea.
Okay, I am share the Google code also. I am sharing the link also. No problem
Link
at all.
also.
Okay.
Okay. So let's start. First, as if you have any questions, so you can ask. Otherwise, I will become in the topic. Yesterday, whatever I discussed in this, this slide, I'm discussing the last. So with this slide, you just check. That is, nothing but a delay of in a mode 1, how to calculate the delay in mode 1. Now today we are calculating the delay in mode 0. First we are starting in a mode 0 because till now mode 0 is not done. Delay formula for mode 0, and which is not also not available in the slide also, but how you calculate is a very easy. And then mode 2, and then we are proceed for the program. Some program for mode 1 and mode 2. Just see my copy where I explain how to get in mode 0. So in mode 0, say instead of in a previous day, whatever I discussed in the previous day, that is, I'm starting with ABCD. I'm starting with ABCD, and it will be continue up to FFFF. I'm starting with ABCD, and it will be continue up to FFFF in mode 0. It is sorry, in mode 1. It is in mode 1. It is in mode 1. But if I'm talking about that is the ABCD and FFFF, so it will be in mode 1. But what will be the in mode 0? Mode 0, it will not be continue up to FFFF. It will be continue up to FF1F. It will be continue up to FF1F. Means it will not be ABCD. It may be AV0D. It may be AV0D, not CD. And it can be continue up to, it can be continue up to, up to, it will be continue up to FF. First, after that, it will be AB0E. Next, up to AB, how much? AB, how much? Sir, whatever the mode 1, mode 0. Mode 0 is nothing but a 8-bit for THX and 5-bit for TLX. 8-bit for THX and 5-bit for TLX. 8-bit for TLX. So 8-bit for THX and 5-bit for TLX. So what will be done, sir? Yeah, after AB0E up to how much? AB, how much? It will be up to AV1F. It will be up to AV1F. It will be up to AV1F. It will not be more than 1F. It will not be more than 1F. So up to AV1F. Why? Because it should not be greater than the 1F. It should not be greater than the 1F, because here 5-bit for TLX. Here 5-bit for TLX. So it should not be more than 1F. 1F is the maximum value. 1F is the maximum value. You cannot get more data, or after 1F is not possible, as it is nothing but a 5-bit for TLX. So next it will be AC00. Next up to AC1F. As so on, AD00 to up to AD1F, and if I'm continue, it will be up to FF1F. Up to FF1F. So, sir, if I am eliminating these portions as in the previous day, if firstly we are eliminating these portions, then we are calculating these portions only, calculating only these portions. So what will be the, how many counts will be there? First, count these portions only. First, count these portions only. So it will be how much? It will be nothing but a 0, 0 to 1F. 1F is nothing but a 31. 1F is nothing but a 31. So 31 means 0, 0 to 31 means it will be as per the previous day, 32 count will be there. 32 count will be there, 0, 0 to 1F. Next, sir, from AD0 to AD1F, again it will be 32 count. Again it will be 32 count. So you know, every increasing of AC to AD, AD to AE, AE to, you know, AF, as so on, every time it will be count 32 more. It will be count 32 more. So how, you know, we are calculating? We can say similarly in the previous day, FF, this FF minus AC plus 1 into 32. As you know, every time it will be 32 count. As you know, every time it will be 32 count. So, you know, FF minus AC plus 1 into 32. So what will be happen, sir? FF minus AC plus 1, as sir, how it will be coming? As yesterday I told to you that, you know, if counting from 2 to 5, if counting from 2 to 5, so how many counts? 5 minus 2 plus 1. 5 minus 2 plus 1. If I am counting, that is a 2 to 5, then is nothing but a, you know, I am telling about first, if I am counting from 2 to 5, then it will be,
वो मैंने कनेक्ट कर लिया। नहीं, वो जो बोल रहे गूगल फॉर्म वगैरह जो मिलेगा आपको, है ना, जो नोट्स मिलेगा, वो बोल रहा गूगल क्लासरूम में है। तो जब तक गूगल क्लासरूम ज्वाइन नहीं करेंगे वो आपको नोट।
so FF minus AC plus 1. So basically, you know, FF minus AC, FF minus AC plus 1, that will be, you know, nothing but a your value. Means from FF to AC, how many counts will be there? Plus 1, because if you am calculating 2 to 5, then 5 minus 2 plus 1, counting from 2 to 5, you know, 2, 3, 4, 5, 4 count. So 5 minus 2 plus 1, that is the formula. So 6 minus 2, that is the 4. On the other hand, if AC to FF count means FF minus AC plus 1, as every time it will be 32 count, so multiplied by 32. So what will be happen? FF minus FF plus 1 is nothing but a 256 minus AC into 32. So what will be happen, sir? 256 minus, what do you mean by AC? AC is nothing but a, sir, AC is nothing but a AB plus 1. AB plus 1. AC is nothing but a AB plus 1. What will be the AB? AB is nothing but a value of THX. So over here we can write down THX plus 1 into 32. So in this way, or in these portions, you know, we can easily calculate that these portions how many counts. So next, what are the count in these portions? Only these portions. This portion is nothing but a 1F minus 0D, 1F minus 0D plus 1. So we can say this portion is nothing but a 1F minus 0D plus 1. What will be happen, sir? 1f plus 1 means 32 minus 0d. On the other hand, we can say 0d is nothing but it is the THX value, it is the TLX value. So 32 minus TLX. What is the TLX? I already discussed yesterday. TLX may be TL0 or TL1. Maybe TL0 or TL1. This is the lower part of the timer 0 or timer 1. It's the lower part of timer 0 or timer 1. So next, so we are just adding these portions, that is 32 minus TLX. So over here also plus 32 minus TLX. Over here also 32 minus TLX. So what will be the total, time period or total time required to execute the above, calculations or above, counting into total into 12. So it will be convert in a T state divided by FOSC. So it is nothing but divided by FOSC is nothing but your time will be calculated. Next. So in this way, so that is the formula of, mode 1. It is the formula of mode 1. It is the formula of mode 1. If time is required, so total into 12 by FOSC, frequency of oscillations. Why into 12? 12 is nothing but is used for counting, calculate the T state, and FOSC is nothing but a frequency of oscillations. Frequency of oscillations. Sir, next portion, that is, if I'm talking about if I'm talking about the next portion, that is the mode. That is nothing but a mode 2. Mode 2. So in mode 2 means nothing but it can count maximum 002 FF, where the initial value store into the THX, and TLX is used for counting the value. TLX is used for counting the value, and THX is used for store the initial value. So how it will be done, sir? Say here ABCD initial value is not possible because maximum count is FF. So below FF you can given the initial value. Say I am given AB. AB is the given the initial value. So it will be count up to FF. So how many counts? Over here it is a very simple one. It's nothing but a FF minus AB, FF minus AB plus 1. That is the number of count, as same as if 2 to 5 count, 5 minus 2 plus 1, 5 minus 2 plus 1. So it is FF minus AB plus 1. So that will be nothing but a, if I am given using the formula, so FF plus 1 is nothing but a 256. And AB is nothing but this is the initial value. Always we have stored the initial value into the THX. Always we have stored the initial value into the THX. We have stored the initial value into the THX. So what will be happen? It will be nothing but a THX. So 256 minus THX, that is the formula, which is used for mode 1. Which is used for mode 1. Sir, next, that is the we are already calculating mode 0 and mode 1 and mode 2, how you were calculating and all. So next we are coming some programs. Yesterday we are discussed about those kind of things, and now we are given a 3 different program for you. Already we are doing this kind of program, so you can do this 3 program. So we are coming into the next, that is a mode 2 programming and all. So before mode 2 programming, how mode 2 will be working, you know, this is the mode 2 and this is the formula. 256 minus TLX or THX, whatever you say, THX, it will be the best. So 256 minus THX into 12 by FOSC, as we are, you know, in our copy we are doing the same. THX 256 minus THX into 12 is nothing but this is a time, into 12 is nothing but a used for calculating the how much, you know, T state is required, how much you know T state is required, and FOSC is nothing but a frequency of oscillations. FOSC is nothing but a frequency of oscillations. It is required, you know, for calculating the time delay. Next, just see when C oblique T bar, then this is nothing but a timer operations. Then internal clock pulses, counting by the by the, you know, counter. But remember, whenever the timer is overflow, means whenever after FF, it will be automatically reloaded the value of THX. It will be automatically reloaded the value of THX. So, you know, TLX always starting from the initial value which is stored into the THX. So the value of THX will be automatically stored into the TLX, you know, after operation is completed, means after calculation is completed, after FF, it will be automatically started from the TLX. The next, coming into this part, here nothing but a split timer mode. In split timer mode, its 8-bit is used for the TL0 and 8 bits used for the TH0. You know, TL0 is set the flag of TF0 and TH0 is set the flag TF1. Whatever I told, that is TL0 used as a, you know, timer 0 and TH0 used for timer 1, and that is the function of this. Next, this is the next program, and this program is nothing but a mode 2 programming. Just see, is very important mode, that is a mode 2. In this mode, we are just given this is the program, you know, and where we are using P1.0 as a square wave. When will we get a P in P1.0 in a square wave? Very good. Sir, what will be the functions of this? So first we are using the timer 1 in mode 2. Timer, any timer you can use, but we are using in timer 1. We are using the timer 1. So sir, timer 1 mode 2, what will be the value of timer 1 mode 2? If I am talking about the timer 1 mode 2, just see my copy, timer 1 mode 2, again I starting from the T mode, this is the gate pin, this is nothing but a C oblique T bar, this is nothing but a M1, this is nothing but a M0. Same over here, gate pin, C oblique T bar, M1 and M0, right? Remember, these 4-bit will not be used as we are using, it will not be used at, this is nothing but a timer 0. This is nothing but a timer 0. We are not using the timer 0. We are using the timer 1. So how timer 1 will be operating, or timer 1 will be, you know, work on the field. So timer 1 is basically is used for this one. As we are using the timer 1 in mode 2, first mode 2. Mode 2 is nothing but a 1 0. Mode 2 is nothing but a 1 0. Mode 3 is 1 1. Mode 1 is 0 1, and mode 0 is 0 0. So that is the M1 and M0. I already discussed in the previous day. That is the what are the functions of M1 and M0. M1 and M0 is nothing but I used to select the mode, various mode. As mode 2, so 1 0. So C oblique T bar, it should be 0, as we know we are using the timer operations. We are using the timer operations. If we are using the counter operation, then it will be 1. And gate we are not set, it will be set by the hardware. So, and as it is not used, so all are 0. So what will be the value? It is 2 and it is 0. So it will be 20. It will be 20. So that's why you just see my slide. Move T mod, comma has 20H. What are the functions? Move T mod, comma has 20H is nothing but a, sir, you know, T mod means timer mode will be 20H. Timer mode will be 20H. What are the functions of timer mode will be 20H? Timer 1, mode 2. It is a function is nothing but a, we are using timer 1, mode 2. Now I already explained in my copy. So timer 1, mode 2. So next, sir, move TH1, comma has 05H or has 5H. What are the functions? So initial value stored into the TH1. So it means it will be count from 5 to 255. It will be count from 5 to 255. I'm repeat once again. Initially, you know the value of TH1 is 05H. Initially, the value of TH1 is 05H. Initially, the value of TH1 is 05H. So, you know, it will be count, that is the timer will be count for 05H to 255. 05H to 255. Next, SetBTR1. What are the function of SetBTR1? Corresponding timer will be start. TR1 means timer one, timer 1 will be start. SetBTR1 is nothing but a timer 1 will be start for counting the clock pulses. TR1 means timer 1. So timer 1 will be start the clock pulses. Next, sir, JNBTF1 back. What are the functions of JNBTF1 back? Is a very important thing, you know. Whenever timer 1 is overflow, whenever timer 1 is overflow in that particular time, whenever timer 1 is overflow in that particular time, this corresponding bit, that is the TF1 bit, will be automatically set. So it will be count. So it will be count. Just see my copy that it will be count from 5 to FF. So after FF, it becomes 05H again. But remember, in that particular time interval, TF flag will be set. In that particular time interval, TF flag will be set. I am repeat once again. We are given the initial value 5. So it will be start the counting from 5, 5, 6, 7, 8 up to FF. After FF, it will not be 0. It will be again 05H. At we are using the mode 2. As we are using the mode 2, mode 2 means auto reload mode. If the value, whatever I am given into the TH1, it will be automatically loaded. It will be automatically loaded. So that's why, you know, the value of TH1, that is the 5. This 5 will be automatically stored. This 5 will be automatically stored into which registers? Into the TL1 registers, because the value of TH1 will be automatically loaded into the TL1. TH1 is automatically loaded into the TL1. TL1 is used for counting the clock pulse, and TH1 is used for the store the initial value. So we have stored the initial value. Count till now, after these two line, counter will not be start for counting the clock pulse until we are given the TR1, SetBTR1. Whenever we are given SetBTR1, means timer 1 will be start for counting the clock pulses. After given, you know, this bit, corresponding timer will be start for counting the clock pulses. For counting the clock pulses. I am repeat once again. It will be start from 5. It will be continue up to FF. You know, after 5 to FF, it will be again become 00H. But it will not be start until we give SetBTR1. Until we give SetBTR1. Whenever I give the SetBTR1, whenever I give SetBTR1, what will be the functions? Functions is nothing but a after this set be TR1, corresponding timer 1, timer that is a TR1 means timer 1, timer will be start the clock pulses. From where? It will be start from the 5 and it will be ending at FF. After FF, this TF1 flag will be 1. So whenever counting is going on, means 5 2 to 55 means 5 to FF means 5 to FF. This bit will be 0. This bit will be 0. So what are the functions of JNB? JNB is nothing but a jump at not bit. JNB is nothing but a jump at not bit. If if this bit is set, then you will be coming into this line. Otherwise, if this bit is reset means 0, then this line will be repeated once again and once again until this bit is 1. Whenever this bit is 1, then coming into the next line. What are the function of the next line? Next line is nothing but a CPL P1.0. What are the functions of CPL P1.0? Just complement of P1.0. Just see, if I am talking about the previous J program, what will be the significant? Set be TR0, but after JNB, we are clear the TR0, because if not starting from FF, F2, it will be starting from 0000H. It will be starting from 0000H because it's not loaded the initial value. It will not be loaded the initial value. Initial value we are given again. So that's why so initial value we should be given again. So that's why we are not using this kind of things. It means the CLR TR0, because here this value automatically loaded. We need to store again into the TH1. So that's why we are not stop the timer for counting the clock pulses, because every time it will be count from 5 to FF. So that's why only CLR TF1 and CLR TF1 and CPL P1.0. What are the functions of CPL P1.0? CPL P1.0 is used basically for complement of P1.0. So before the instructions may be 0. So after the instruction it will be 1. So after the instructions it will be 1. After the instructions it will be 1. So CLR TF1, what are the functions? This TF flag, which is automatically set by the corresponding timer, it will be reset, because whenever in the next time for the next clock pulses, next counting from 5 to FF, then if it is 1, if it is not clear by 0, then this line will not be repeated once again. This line only repeated 1 times and coming into the second line. So to wait 5 to 255 means 5 to FF counting, we are using this JNB TF1. As TFX bit. TFX means TF1 or TF0. It will be set by the hardware. Yesterday I discussed regarding this. It is set by the hardware, but it reset or clear by the software or us. So that's why it's clear by us. That is CLR TF1. And is jump back means jump from this line to that line, and this line will be repeated once again and once again and once again. So that is the functions, that is the function of mode 2. Sir, every time we don't know what are the frequencies and all, what are the calculations and all. Next we are coming in the program where we are calculating the same. Next, first I am giving another mode 1 program. It's clear to everyone, or if you have any queries, so you can ask. If you have any kind of queries, so you can ask. I am happy to answer in this mode, in this program. Okay, I'm going into the next. That is the next program. This is this program. Everyone can see now. Everyone see? I think it's visible.
Yes, clearly visible.
Next, just see CLR P2.3. I'm discussing this program. Next, I will be discuss this program. So first just see CLR P2.3. This is nothing but a mode 1 program. So mode 1 program, you know, you will be stored the initial value as we are given the initial value B83E. We are given the initial value B83E and which timer? Timer 0 mode 1. As we are using mode 1, so timer 0 mode 1, it will be 01. I am not, you know, explain once again. If it will be explained the previous day. If I am talking about, you just see move T mod comma as 01. So same program, this is the same program, this is the same program. So move T mod comma has 01H. So move T mod comma 01H, and you know here it is nothing but a used for, it is nothing but a used for uh, firstly it will be the clock pulse is generated in P2.3. P2.3 initially it is 0, initially it is 0 P2.3, then given we are initial value that is B83E, then set B P2.3 means it will be 0 to 1. Next, set B TR0. What are the functions of set B TR0? Timer 0 will be start for counting the clock pulses. Timer 0 is used for counting the clock pulses. The timer 0 is used to start counting the clock pulses. I am repeat once again. Timer 0, you know, timer 0 is used to count the you know, timer 0. Timer 0, after this line, timer 0 will be start for counting the clock pulses. After this line, timer 0 will be start for counting the clock pulses. Next, sir, JNBTF0 again. JNBTF0 again. So what are the functions of JNBTF0 again? Sir, nothing but these instructions will be you know, these instructions will be repeated once again and once again until TF0 is equal to 1. So when TF0 is equal to 1, when B83E, it start from B83E, it start from B83E. Why B8? Before B8 is 0, because I already told to you, you know, to distinguish between character and number, we are connecting a 0 before any number. So it is a number, so I am connecting with a 0 before that. So B83, it will be count from B83 to FFFF, and in that particular time interval means whenever we are counting B8 to B83 to FFFF, in that particular time interval TF0 will be 0. TF0 will be 0, and what will be happen? TF0 will be 0 means JNB, jump at not bit. Jump at not bit means whenever TF0 is equal to 0, this line will be repeated once again and once again and once again. Whenever this, you know, this TF0 bit is, whenever this TF0 bit is equal to 0, then jump once again and once again and once again. It will be repeated. You know, it will be repeated several times. This line will be repeated several times. Next, the CLR TR0. What are the functions of CLR TR0? CLR TR0 is nothing but a you know, CLR TR0 is nothing but a clear that timer, you know, stop the timer 0. CLR TR0 is nothing but a use for stop the timer 0. This is set B TR0 is used for start the timer 0 for counting the clock pulses, and it's nothing but a clear TR0 is nothing but a stop the counting. Means why say stop the counting? Because you know, if I am not stop the counting, then what will be happen? You know, this, if I'm not clear this TF0, then after B83 it will be becomes in increment and increment and increment. It will be once upon a time it will be FFFF. After FFFF it will be 0000. It will not be start from B83. It will not be start from B83, but we want to start it from B83. Why, sir, it will be start from B83? Why we start from the B83? sir, it will be given a clock pulse like that. Just see my copy. It will be given a clock pulse like that. It will be given a clock pulse like that. So this time and that particular time should be equal, and it will be generated by delay. How much delay, sir? It is nothing but a B8 3 to FFFF count delay. B8 3 to FFFF count delay. If it is a square wave, I want to generate a square wave, so it should be B8 3 to FFFF count. It should be B8 3 to FFFF count. So basically, it should be B8 3 FFFF count, and it should be B8 3 FFFF count. So basically, if it will be starting from 0000 to FFFF count, then this program will not be correct. This program will not be correct. So how, sir, it will be done? How it will be done? It will be done nothing but a B83 to FFFF count over here and B83 FFFF over here. So after FFFF it becomes 0000H. So in that particular time we should be stopped. We should be stopped timer 0. We should be stopped timer 0. We should be stopped timer 0. CLR TR0. Using CLR TR0 means we will be stopped. We will store again. We will store again B83E. We will be stored again B83E. So after again store the B83E, we again start the timer. So that's why we are stopped CLR TR0. Timer 0 will be stopped. What are the functions of CLR TF0? TF0 is nothing but a timer flag, timer overflow flag. After these instructions, timer overflow flag will be 1. Otherwise, it will not be come in the second line. It will be repeated once again and once again. And when TF0 flag will be set, after FFFF, after FFFF, after FFFF, when it becomes 0000, after FFFF, when it becomes 0000, in that particular time interval, TF0 bit will be set. In that particular time interval, TF0 bit will be set. So what will be happen, sir? It's a very simple thing. It's a very simple thing. Remember, after B83 it will be FFFF, and after FFFF it will be 0000H. So 0000H to count FFFF it will be start. So to stop the 00H count to FFFF count, we should be start from B83 to FFFF. That's why we stop CLR TR0. Again CLR TF0 means this flag will be reset again, because in the next time whenever we are coming in this line, otherwise this line will not be executed. Then CLR P2.3. What are the functions of CLR P2.3? It is a very important one. CLR P2.3. CLR P2.3 is nothing but a port 2 or port 2.3 will be 0. Port 2.3 is equal to 0. So basically, if I am repeat this program once again and once again and once again, then you will be get a square wave. So first it will be it will be 0, then it will be high, then it will be it will be high till it is end. So this like a pulse you will be get over here. So next question is that what are the delay? How much delay program is there? Just see, my formula number 1 is applied over here. That is FFFF minus B83 plus 1. FFFF minus B83 plus 1. It is 47C2 is equal to in decimal 18370. So 18370, 18370 in decimal. So if one machine cycle is required 1.085 microsecond. How, sir? Because if crystal frequency is 11.0592, whatever I am discussing the yesterday, then 12, one machine cycle required 12 t-states. So 12 by 11.0592. So basically is nothing but a 1.085 So 1 point into 1.085 is equal to 19.93145 microsecond or milliseconds, whatever you can say. So with the help of that, you know, this microprocessor, this delay will be generated 19.931. On the other hand, it can be calculation like that. You know, it is a decimal, so 65536 minus 47166, so you will be get the same, the value will be the same, no issues. Next question is that when this program will be generate the maximum delay, in this program it will be generate the maximum delay. When maximum delay will be generate, maximum delay will be generate when the value of TH0 and TL0 will be 00H. TH0 and TL0 will be 00H. So it will be count from 0000H. It will be count from 0000H up to FFH. So it will be long delay. It will be long delay and calculate the delay. So just see this program and this program basically same. There is a no change. Only change is that B83 will be replaced by 00. B83 will be replaced by 00 because it will be, you know, given the maximum time delay. It will be given the maximum time delay. So I'm repeat once again. This program when given the maximum delay. This program when given the maximum delay. This program when given the maximum delay. Nothing but the answer is nothing but, sir, this B83 should be the lowest value. Means this B83 should be 0000H. So 0000H to FFH count means it's a long delay. It's a long delay. It's a maximum delay. So I'm just write the same program using 0000H, and you know this whenever I'm calculating 65536 minus 0 because I am given a 0. And you know, so 65536, before that we are using 65536 minus 47166. From where you are getting 47166 is nothing but the B83 decimal value. B83 decimal value 47166. So it will be into 1.085. So it will be maximum delay is 71.1065 microsecond. Sorry, millisecond. That is the delay which is generated by this program only. Next we are coming in the next program. Now till now we are calculating the delay, whatever, you know, program is set by us. Program is set by us, and after that we are calculating the delay. But next question is that if the question is just like that, if you need 2 kilohertz frequency, what will be the program? 2 kilohertz frequency, what will be the program? So it's a very interesting. I will be coming in the next one. That is if the crystal frequency is maybe 12 megahertz or maybe 11.0592. Say I'm assuming that the crystal frequency is 11.0592 megahertz. Then I will be calculate if say given X kilohertz frequency you are generate, X kilohertz square wave you will be generate. So how it will be calculate? I'm coming in the next one. So microcontroller in that particular time used as just like a function generator. So basically, sir, in this program we are generating 2 kilohertz frequency. We are generating 2 kilohertz frequency. You know, it is a generating a square wave of 2 kilohertz frequency in pin number 3.1. So how it will be done? It's a very important question. How it will be done? Next, sir, just see T is equal to 1 by F. What it is given F. So what will be T? T is nothing but a 500 microsecond. So how I am get? As we know, T is equal to 1 by F. So we are given a T. So I am calculating T. You know, F is given. So T is equal to nothing but a 1 by F is equal to 500 microsecond. So from where I am getting T on and T off. So from where I am getting T on and T off. I am getting T on and T off. So T on and T off, it will be 250 microsecond. it will be 250 microsecond. It will be 250 microsecond. So how it will be 250 microsecond, sir? Because you know 500 is equal, if 500 is t, is 500, t is equal to 500. Just see my copy. Just see my copy. If t is equal to 500, then if the square, it is the square wave. If this is a perfect square wave, so this is a t on, this is the t off. So as we know, t is equal to t on plus t off. As we know, t on is equal to t off. As we know, t on is equal to t off. So what will be happen, sir? T on is equal to t off. So what will be happen, sir? Is nothing but a, it is t by 2. So we can say t on is equal to t by 2, or t off is equal to t by 2. So I am just doing the same. It will be 250 microsecond. So 500 to it will be 250 microsecond. So how many count is required? How many count is required? As we know, for one machine cycle we need 1.085 microsecond. For one machine cycle we need 1.085 microsecond. Sir, how it will be generate? How it will be get? You know, one machine cycle required 12 T state. So 12 T state, and what are the frequencies? I am assuming that is the frequency is 11.0592 megahertz. So if we are doing the same, we will be get 1.085 microsecond. 1.085 microsecond. So with the help of that, we are getting 1.085 microsecond. And you know, with the help of 1.085 microsecond, we are getting the calculate value, that is the counting value. So 250 microsecond by 1.085. 250 microsecond by 1.085. So what will be happen? 256 minus 1, you know, divided by 1.085, it will be 230. If you are calculating it, you will be get 230. So what will be the value of, you know, initial value? Initial value is nothing but a value of THX and value of TLX. Value of THX and value of TLX. Here is not mentioned in any timer, so you can use any timer. Over here it is used timer 1. Over here it is used timer 1, but you can use any timer. Next, just see. So 65536 minus 230 is equal to 65306. As we are discussed this three formula, if I am going in this slide, 65536 minus NNNNN into 1 microsecond if 12 megahertz. So we are doing the same things, you know, 65536 minus 230. So what will be the value? That is a 65306. If I am converting to the hexadecimal, that is FF1A. That is FF1A. So FF is the value of THX and TLX will be 1A. FF will be value of THX and you know, 1A is the TLX. Sir, if we are using timer 1, then sir, if using timer 1, then it will be, sir, the FF is the value of TH1 and 1A is the value of TL1. FF is the value of TH1 and you know, 1A is the value of TL1. So just see, move again 10H. 10H is nothing but a timer 1 mode 2. We are using timer 1 mode 2. That's why 10H. And I'm storing the value TH1 and TL1. I am storing the value TH1 and TL1. TH1, FFH, TL1, 1H. This is the value where I stored TH1 and TL1. So you know, this is the value of TH1, this is the value of TL1. We are storing FF1A and set BTR1. So after this instruction, timer will be start for counting the clock pulses. Timer will be start for counting the clock pulses. Means after FF1A to FFFF. And in that particular time interval, this line will be repeated once again and once again and once again. This line will be repeated once again and once again and once again until it is FFFF. Means until counting is over. Whenever counting is over, coming into the next line. Whenever counting is over, coming into the next line. What are the next line? Next line is nothing but a CLR TR1. What are the functions of CLR TR1? Is nothing but a clear TR1 means timer 1 will be stopped for counting the clock pulses. Timer 1 will be stopped for stop the counting. Timer 1 will be stop the counting. Because if I have not stopped the counting, that it will be count from 0000H to FFFH, which I don't want. I want to start again from FF1A. I want to start again from FF1A. So that's why after FF1A, I will be continue up to FFFF. Next, my question is that CLR TR1. What are the functions of CLR TR1? Is nothing but a TR1 will be becomes 0. Next, CPLP 1.5. What are the functions of CPLP 1.5? CPLP 1.5 is nothing but a P1.5 is complement. P1.5 is complement. And CLR TF1. What are the functions of CLR TF1? Means clear TF1. Means this after this bit TF1 will be set. So it will be just reset. It will be just reset. So CLR TR1, CLR TR1, stop the timer, and CPLP 1.5 is nothing but a complement P 1.5. What are the functions of complement 1.5? As we know, it is a square wave. So first time it is 1, so next time it will be 0. That's why it is a complement. Complement means just toggle with the previous value. Next, CLR TF1. What are the functions of CLR TF1? Whenever next time we are coming, it will be set as a TF1 is a set, otherwise it cannot come in the next line. So it will be just clear. Yes, jump again jump from this line to that line, again store the initial value, again this procedure will be continue once again and once again. Then it will be generate 2 kilohertz square wave, 2 kilohertz square wave. Similarly, if you need 4 kilohertz, it can be done. It can be 8 kilohertz, it can be done. 50 kilohertz, it can be done. So whatever the frequency you require, you can use the microcontroller just like a function generator. Any kind of frequency you can generate. Next, this is the timer operation. Till now, we are discussing about the counter operations. We are using the timer operations. Now we are discussing about the counter operations. Till now we are discussing about the timer operations. Now we are discussing about the counter operations. So in counter operations, C/T bar should be 1. C/T bar should be 1. So counter operations. What are the program? I am given an input on a clock 1, that is a pin 3.5. We are given a clock pin 3.5. If I am talking about, then you can see that is the P 3.5 is nothing but a T1. T1. So T1 in T1 pin, you are getting a clock. Getting a clock in T1, and it will be display on port 2. It will be display on port 2. It will be display on port 2. That is our functions. So which mode we are using over here? Counter 1 mode 2. Counter 1 mode 2. So just see, it will be given in a binary. It's a very interesting things. It is a given in binary. So as T1, so we should be talking about counter 1 or timer 1, whatever it is. If we are talking about the counter 1, we will not be consider the counter 0. So this 4 bit is for counter 0, which should be 0. This 4 bit, as you know, this is for counter 0 operation. So all bit should be 0. All bit should be 0. Next 4 bit, it's a very important thing. Next 4 bit 0110. What are the functions of 0110? It's a very important thing. Just listen carefully. Just see 10. This is nothing but a mode 0. 10 is nothing but a mode 0. And why this is 1? C/T bar is 1 means it's a counter operation. Means it's a counter operation, and get pin not set by us, it's set by the hardware. Anyone want to say something? Anyone want to say something? Okay, maybe by mistakes. And if anyone is don't want to say, so I am continuing again. You know, 0000 h. So this 0000 h is not used as we are using the counter 1, not counter 0. So this 4 bit is equal to is 0000 h. Next, as mode 2, so 10h. As mode 2, so it will be 10h. It is nothing but M1 and M0. It is nothing but a M1 and M0, 10. It is 10 means it is a mode 2. Next, it's 1, as it's 1, nothing but a, this one is nothing but a for counter operation. C oblique T bar is equal to 1 is nothing but a counter operations. Next, it's 0. It's a gate pin not set by the us, set by the hardware. So it is not set by the us. So it is a, you know, it is these are the value which is stored into the T mod. So T mod will be this value. So timer 1, a counter 1, mode 2 operations will be performed. Counter 1 and mode 2 operations will be performed. It's a very significant thing that whenever we start the counting, we are always our initial value is 0. We are start the counting means if say how many students are there, you are counting. So always starting from your initial value is 0. We never starting that initial value 10, 5, 15, something like that. So as we are counting the clock pulse, so just see move th1 is equal to 0 means we are given a a 0 with we given a 0. Given a 0 means it will be start from 0, it will be ending at ff. It will be start from 0 and it will be ending at ff. So so it will be start from 0, it will be ending at ff. That's why I'm given an initial value th1 is 0. Why is th1? Why not tl1? Because we are given the initial value into the th1, it will be automatically loaded into the tl1. Remember, in mode 2, we are not given the initial value into the tl1, it is always given into the th1 or th0. Higher part, a higher byte of timer 0 or timer 1. So it will be automatically load the lower byte means TL0 or TL1. Next, at set BP 3.5. What are the function of set BP 3.5? It's nothing but a set P3.5 will be 0. P3.5 will be 1. After this instruction, P3.5 will be 1. Why, sir, P3.5 will be 1? Because you know, before I already discussed, by default, all the pins, all the port are used as an output port. All the pins will be used as an output port. Whenever you need as an input port, you should be write a program. Program means program is nothing but you given a high signal at the beginning of the program. A high signal at the beginning of the program, or before use this pin. Before that, you should be given a high signal on them. So microcontroller will be understood that this pin will be act as a input pin. So that's why I'm given to used as an input pin. I given a set BP 3.5 is equal to 1. So next, set B TR1. What are the functions of set B TR1? Is nothing but a timer 1 will be start for counting the clock pulses. Timer 1 will be start the counting the clock pulses. Next, what are the functions? Just see, it's a very interesting thing. Move A, TL1. Move A, TL1. What are the functions of move A, TL1? Move A, TL1. What are the functions of move A, TL1? Is nothing but a, just see, move A, TL1. What are the functions? Is nothing but a, the value of TL1 means whatever the counting value, it will be stored into the accumulator, and that will be stored into the port 2. And that will be stored into the port 2. First, it will be stored into the accumulator, and then it will be stored into the port 2. So first, the value of TL1, it will be stored into the accumulator. Then, the content of accumulator will be stored into the port 2. Next, JNB-TF1 back. What are the functions of JNB-TF1 back? It's a very interesting thing. It's another very interesting thing. Jump at not bit. Always we are using the same line. But we are given over here because 0, it will be 0, display 0, display 1, display 2, and so on and so forth. Means 0 to 255, it will be display on port 2. 0 to 255 it will be display on port 2. 0 to 255 it will be display on port 2. That's why I've given a back over here, means the value of TL1 will be automatically stored into the accumulator and the content of accumulator will be coming into the port 2. So JNV TF1 back means jump from this line to that line. Next, CLR TR1. What are the functions of CLR TR1? Means timer one run control bit is 0, means timer will be stopped for counting the clock pulses. Timer 1 will be stopped for counting the clock pulses. And CLR TF1. Sir, why it is required? This timer 1 is stop the counting because we are using the mode 2. We are not using the any other mode. So it will be auto start from the initial value. Sir, why I am stopped this timer? Because if we execute these two instructions, jump over here, maybe one counting is over. So that's why I'm clear CLR TR1 means it will be stop the counting. Next CLR TF1 means this TF flag is set, it will be 0. Then S jump again will be jump over here, means set BTR1 again. The timer will be start for counting the clock pulse, not given the initial value again. It will be automatically set. So I'm just given set BTR1. So with the help of that, our timer and counter operation is over. If you have any kind of queries regarding this program, you can ask, no issue. Sir and madam, if you have any kind of questions, you can ask up to the timer, because my timer is over. Next we are going into the serial communications. You have any kind of queries?
No, sir. Please continue, sir.
Okay. So next portions will be going into the our serial communications. For serial communication, these are the counter operations. Counter operations means C oblique T bar is equal to 1. Then you will count the external clock pulses. C oblique T bar is equal to 1. Then count the external clock pulses. That is shown over here. It is auto reload mode. It is a 16-bit timer mode. That is a mode 1. And whatever the program, last program, this is the same program. It's nothing but how with a diagram. Here LED is there. Just see in 3.5 some clock is coming into the microcontroller and it will be display on port 2. Whatever the last program, that is nothing but the same program, just drawn with a diagram. Just P3.5 given a clock and it will be display on port 2. This is a serial communications. Serial communications and parallel communications. There are two types of communications. Parallel communications means 8 bit can be transferred at a time, but serial communications 1 bit per at a time. Without 1 bit is not possible. When the long distance, we are using the
জোরধারে এখন যাব না, সে সন্ধ্যাবেলায় যাব। রবিতে ছাদে।
Saptarshi, please mute. Mr. Saptarshi Mukherjee, please mute. Then you speak. Just I will be enter after that. This is the interrupt, and this is nothing but an example of interrupt, nothing else. So I'm just coming into the next part is the interrupt. What is the requirement of interrupt? So, but before already interrupt is entering. So forget about it. I'm just start once again. That is nothing but a C synchronous and asynchronous. There are two types of data transmissions in the serial communications. Whenever the long distance communication, we are going into the serial communications, synchronous communication and asynchronous communications. I just give an example of synchronous communication, and I will be given asynchronous communications. First, I explain a topic. What is the PC? PC is nothing but a program counter. The next instruction to be executed, the address of the instruction stored in the PC, that is the function of program counter. So are you able to understood whatever I say? I'm repeat once again. Okay, I'm repeat once again. What is the function of PC? PC is nothing but a program counter. The next instruction to be executed, the address of the instruction stored in the PC, that is the function of program counter. Are you able to understood?
No,
Answer
sir.
is
It was
no,
very
sir.
fast.
No, sir. It's a very fast. So I am the faster device. Means processor, microcontroller is the faster device, but the other peripheral, is the slower device. So whenever communicate, if communicate, we without getting the acknowledgement from the slower side. So if we send a block of data, then the data will be lost. Then the data will be lost. Then the data will be lost. So how this problem will be solved? Whenever speed mismatch, we are in a same platform. We are not, we don't have any, same kind of speed. Whatever my speed and your speed, maybe your speed is higher, maybe my speed is lesser. So with respect to each other, our speed is mismatch. In that particular condition, we are going into the asynchronous modes. In synchronous modes, what I am doing, what is the PC? PC is nothing but program counter. The address is stored in the PC, that is the function of program counter. Are you understand? If yes, means you are given me a positive acknowledgement, I will be send another data. Means a block of data. After that, I getting a acknowledgement from you. Whether you have given a positive acknowledgement, so I will be give the another data. If you are not given the positive acknowledgement, I will be given once again. But on the other hand, I can be displayed like that. I can be explained like that. What is the PC? Yes, sir. PC is nothing but a, yes, sir, program counter. Yes, sir. The, program counter is nothing but a, yes, sir. The next instruction, yes, sir, to be executed. Yes, sir. The address of the instruction, yes, sir. Stored into the PC. Yes, sir. That is the function of program counter. Yes, sir. So yes, sir is given by your end. So I am given a data, I wait. Whenever you are given a yes, sir, I will be send another data. Otherwise, I will be wait. When you are given a yes, sir, then I will be send another data. Sir, in this way, in asynchronous communications, we are transfer the data. Always we are given a single byte data at a time. Single byte data, and in this frame, there is a 8-bit data frame, in 8-bit data frame, we are transferring the data, that is the D0 to D7, that is the D0 to D7, and this is the start bit, this is the, you forget about it, this is a start bit, and this is a stop bit, and this is a space, and these are the data bit, that is the D0 to D7, these are the data bit. It's called data frame. It's called data frame, and you can call it's a 8-bit UART mode. In this kind of data frame, we are called 8-bit UART mode data frame. Maybe there will be another data frame in 8051. It's called 9-bit UART. In that particular time, maybe depend upon the protocol, it may be the one extra data bit, maybe one extra stop bit, or maybe parity bit. That will be depend on your protocol, whatever the protocol you are using. But maximum cases we are using the extra one data bit. Next, coming into the our 3 types of communications, we already discussed simplex. Simplex is nothing but only one-way communications. Half duplex, half duplex is nothing but a both-way communication, but not in the same time. When communications, then receptions cannot be done, and a full duplex transmission and reception can be done in a both way, the same time. So as we have in 8051 in full duplex communication, so we are using this kind of things. Next, this is a synchronous asynchronous. I already discussed. And remember this value, it is required in the program. How this value I am getting, I will be explained later on. But to generate baud rate means how many bits you are transmitting in per second, that is called baud rate. So you know this kind of baud rate you can select in a 8051 microcontroller. And why it is the value of TH1? Because to generate baud rate, to generate the various baud rate, not depend upon the your crystal frequency, all means to generate the various kind of baud rate, you using the timer one, you using the timer 1 mode 2, timer 1 mode 2. So timer 1 mode 2 means the initial value will be stored into the TH1, it will not be stored into the TL1, because TL1 is using for the counting the value, not storing the initial value. That's why the value of TH1, those value, how this value will be coming, I will be discussed later on in the next another 2 slide. So this is nothing but a SCON register. This is the SBUF register. SBUF register is serial buffer registers. Serial buffer register. And SCON register, what are the functions of SCON registers? Serial control registers. Serial control register. So serial control register is nothing but a SM0 and SM2. These two are used for the mode selections. These two are used for the mode selection. Just see the mode. These two are the 8-bit UART mode, and these two is the 9-bit UART mode. First one is a fixed baud rate. Second one is a variable baud rate. First one is a fixed baud rate, and second one is a variable baud rate. And that is the difference. 8-bit UART fixed baud rate, 8-bit UART variable baud rate, 9-bit UART fixed baud rate, 9-bit UART variable baud rate. So variable baud rate means it will be generated by timer 1 mode 2, and fixed baud rate it will be FOSC by 12 or 24 or FOSC by 32 or 64. It will be when 32 and when 64 I will be discussed when I will be discuss the PCON power control registers. When I will be discuss the power control registers, I will be discuss how it will be work, that when F by 32 and when F by 64. Next, and that is the this third SM2 is used is nothing but a for mode 2 and 3, that is a 9-bit UART mode. It is a generate and interrupt. If I am using the mode 2 and 3, then SM2 is used, otherwise SM2 is not used. Rain, always we are received enable whenever you transmit and whenever you receive, otherwise you cannot transmit, because whenever you transmit you should be get a acknowledgement from your receiver end. So rain is nothing but a receive enable. After set this bit it will be receive enable. All of you can audible to me? All of you can audible? I am audible?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So someone maybe problem. Sorry, sir. It is maybe your problem. I don't know. Anil sir, you don't. I don't know. It's mine. I think it's not my problem. So I'm just continue. And the next, sir, rain is nothing but a receive enable, and TV8 and RB8 it's another two important pin. TV8 and RB8. TV8 is called transmission bit 8, and RB8 is nothing but a receive bit 8. It means if you are doing in a mode 2 and mode 3, if you are doing in mode 2 and mode 3, mode 2 and mode 3, there is a 9-bit UART mode. Extra 1 bit transmit through that particular bit, that is a TB8. Extra 1 bit. 8 bit can store the SBUF registers, but not more than that. So where one extra bit will be stored, it will be stored in TB8 at the time of transmission. And where the received in the whenever the receiver mode, it will be received in RB8. Another 8 bit will be received in SBUF register, but extra 1 bit will be received by RB8. TI is called transmission interrupt flag. At the beginning of the stop bit, beginning of the start bit, at the beginning of the start bit, TI flag will be automatically set. It indicates that I am transmitting a data. So receiver end can ready to receive the data. The receiver end will be ready to receive the data. And what will be the functions of RI? RI is nothing but a receive interrupt. Means at the halfway of stop bits. Remember, at the halfway of stop bit, if I am talking about this this frame, then halfway of stop bit means just like over here, just like middle of the stop bit, RI flag will be set, and TI flag will be set at the beginning of the start bit. Remember, With the help of that, the RI flag will be begin halfway of stop bit. Transmission end can be sent another data. That's why receive RI flag will be set, means it will be the data is received successfully. And next, these are the mode 0, mode 1, and mode 2, and with corresponding their formula, how to calculate the frequency, calculate the baud rate and all. Next is nothing but a PCON registers. We have a program on SCON registers. I will be discussed later on. But before that, I should be discussed the PCON register, that is called power control registers. Power control registers. This bit is there is a different. There is a S mod. S mod is called double baud rate bit. S mod is called double baud rate bit. S mod is called. S mod is called double baud rate bit. Oh, I mute. S mod is nothing but a called double baud rate bit. S mod is called nothing but a double baud rate bit. So what is double baud rate bit? Say you are selecting X baud rate using SCON register, and also you set this S mod bit. So your effective baud rate will be 2x. Your effective baud rate will be 2x. If I am going into the some formulas that see 2 to the power S mod, 2 to the power S mod means if S mod is equal to 1, so it will be multiplied by 2. It will be multiplied by 2. Or if it it will be 0, then it will be multiplied by 1. So that is the S mod bit. If I am talking about FOST by 32, FOST by 64, FOST by 32 is nothing but when S mod is equal to 1, and FOST by 64 when S mod is equal to 0. That is the functions. Next, GF0 and GF1. These two is very important also. That is it's called just like a F0 of PSW. F0 F0 in PSW it is general purpose flag bit. You can store any kind of bit. Means as a registers, you have 8-bit registers over here. You can store any 8-bit data. So here you can store in these 2-bit. You can store any particular bit, either 0 or 1. You can store. It is a general purpose flag bit. PD is called power down mode. PD is called power down mode, and ideal is called ideal mode. What is the power down mode and what is the ideal mode? It's a very important, in power down mode. In power down mode, all the peripherals and the microcontroller are not consuming any kind of power. Only some interrupt can be recognized. Only some interrupt can be recognized, just like a remote. In a remote, whenever connect a battery, it will be going on up to 1 year. It will be going on and going on. So how it's possible? Whenever you are pressing any switch, means you are given an interrupt, then this circuit will be working. And on the other hand, if you are talking about the mobile phone, what will be happen? If you are not talking with anyone's, or you are not sending any kind of message, then also you just see and you just check in the next 2 days, your mobile will be your mobile phone will be dry. Means your mobile phone will not be any charges and any charge. So that's the things I want to discuss. That PD is called power down mode, and power down mode is nothing but a power down mode. In power down mode, it is a very important mode where microcontroller and the peripheral are not consuming any power. Some interrupt can be recognized. And whatever the ideal mode, in ideal mode, sir, GF0 and GF1 is related to F0. F0 functions, whatever I discussed in the PSW, basically the same function of GF0 and GF1. And nothing but the same functions. What are the same functions? Same functions is nothing but it is a general purpose flag bit only. You can store any particular bit, either 0 or 1, you can store. That is the function of GF0 and GF1. And same function of F0 also. So basically these 3 bit, GF0, GF1 and PSW, it is a F0. These 3 bit is nothing but a general purpose flag bit. We are telling about this is a general purpose flag bit. You can store any kind of bit. It's clear to you, sir? Next, what is the ideal mode? In ideal mode, microcontroller and the microcontroller are not consuming the power, but the peripheral are consuming the power. Microcontroller are not consuming the power, but peripheral are consuming the power. That's the difference. So you know, if, with respect to ideal mode and power down mode, with respect to power consumption, power down mode is better than ideal mode with respect to power consumptions. So power down mode is nothing but a not consuming the power by the microcontroller and the peripheral, but ideal mode, microcontroller not consuming the power, but peripheral are consuming the power. These are the program. You can do it. Sir, how those data will be coming? Just see. When you know it is always it will be divided by 32. As you know, it is our crystal frequency is 11.0592. So it is divided by 12, so it will be 9 to 1.6, and 9 to 1.6 by 32. Why 32? Always by 32, because our hardware, what is in serial communication is designed, it will be always divided by 32. So it will be 28,800. So 28,800 divided by 3, so it will be 9600. So 9600 is nothing but a you know, as divided by 3 means it will be -3. So -3, if you are converting into the you know, 2's complement of -3 will be get of FD, or if you want to subtract 256 -3, you will be get FD. Next, it will be divided by 12, so you will be get 2400. If we will divide it by 24, you will be get 1200. So divided by 24 means, you know, it will be E8. So these value I already, you know, told in a first slide. Whenever I discuss, these are the value: -3, -6, -12, -24. That is FD, F4, 40, F4, and you know, E8. Just I will discuss now this one, how a program will be conducted. Then you will be understood how it will be worked. So I am discussing. I want to transmit A. I want to transmit A through 4800. Remember that whenever we are transmit a data, you know, in any medium or something like that, we are transmit their ASCII code. We are transmit their ASCII code. You know, in ASCII code, we are transmit so that the data will be received in the receiver end. You will be also convert into the corresponding ASCII to hexadecimal. Then you will be get the data. So ASCII code we are transmitting. That's why, you know, we are transmitting the just see A with the inverted comma. Next, sir, move T mod comma has 20H, because this is already given that 4800 baud rate. 4800 baud rate means it will be variable baud rate. It will be variable baud rate, and A is nothing but a, you know, hexadecimal value is nothing but a 41. ASCII code is nothing but a 41, and all of you know that there is nothing is saying, so it will be 8-bit UART. So 8-bit UART variable baud rate is nothing but a mode 1. Is nothing but a mode 1. So mode 1, timer 1, timer 1, mode 2, we will be selected because we need to select the 4800 baud rate. I already told, always timer 1 and mode 2 used. No others, you know, timer is used. So timer 1, mode 2. So that's why I'm given a 20 as 4800 baud rate. So 4800 baud rate, if I'm talking about in this table, if you see 4800 baud rate, it will be FA. It will be FA -6. It will be FA. How it will be coming? It will also explain over here. That is 4800 is not there. So whatever it is, 4800 is not there. So 4800 baud rate, I am given a FA. Okay. So FA I am given in TH1. It will be automatically loaded into the TL1. Next, SCON is 50. Remember that we are using which mode we are using? We are using the mode 1. That is 01. That is the 01. SM0, SM1 value will be 01. SM0, SM1 value will be 01. So 01 value, and then, sir, you know, RAIN value should be 1. Rest all are the 0, because that will be not used. TB8 and RB8 not used, because it will be used in mode 2 and mode 3. SM2 is not used. So, sir, you know, 50 means nothing but a 50 means nothing but a, just see my copy, 01, 01, 0000. So these two are nothing but a TI and RI flag. These two are nothing but a TI and RI flag, not set by us. it will be set by hardware automatically. It will be set by hardware automatically. These 2 bit is nothing but a, these 2 bit is nothing but a these 2 bit, these 2 bit is nothing but a TB8 and RB8. These 2 bit is nothing but a TB8 and RB8. This is not set by the us because it will be set in mode 2, and it is nothing but a rain bit. Rain always set for transmission and reception both, and it is nothing but a SM2 is used in mode 2, and it is not by us, it will be set by the hardware, and this is mode 1. So we are given a 50, we are given a 50 in SCON register, so we are given a 50. Next, set BTR1. What are the function of set BTR1? Move SBUF is nothing but a set BTR1 means timer will be start for counting the clock pulses, means 4800 baud rate will be selected. Next, a move SBUF is #A means I want to transmit as you know, I want to transmit A, so it will be given a ASCII code. So ASCII code is given into the SBUF register. Next, here JNB TI here. What are the function here? TIB here means, you know, whenever TI flag is 0, whenever TI flag is 0, TI is nothing but a transmission interrupt flag. Transmission interrupt flag, when it will be set at the beginning of start bit. At the beginning of start bit means when start bit is started, means our transmission is now just started, means our transmission is started, the receiver end can receive. Then CLR TI means TI set by the hardware but clear by the software. So it is before, you know, TI flag is set, we are just going on and going on. When the TI flag is set, we are coming into the next line. That is the CLR TI. So next, there is another program, sir. There is another program, sir. How to set the transmit the fine. Fine means first F, then I, then N, then E. In these 3 lines will be repeated 3 times. One in F, one is I, another is N, another is E. And for 2400, this baud rate will be changed. The value will be changed. Next, this is the interrupt and polling. We have a lot of things today because tomorrow, otherwise I cannot complete. So I just till now entering. Interrupt and polling. What are the functions of interrupt and what are the functions of polling? Sir, interrupt means anytime anyone can asking the questions. Anytime anyone can asking the questions. Whereas polling means you will not be asked the questions, sir. So I will be ask you whether you have any questions. So I will be asked like roll number wise, roll number 1, roll number 2, roll number 3, roll number 4. Say roll number 4 have the question, you know, having a question. So I give the answer, then I come back into the roll number 5. So in the so on, it is a round robin process. One by one after another one. We are I am just asking whether you have a questions or not. So interrupt sometime is required, sometime may not be required. Interrupt is required and interrupt may not be required. If not required, you can mask all the interrupt. Otherwise, non-mask the interrupt, and this interrupt will be working. So in 8051, he already told that 6 interrupt is there. If you are eliminating the reset is the not coming in the picture, because not coming in the interrupt controller or something like that. Reset is the always highest priority. Otherwise, you have a 5 interrupt if I'm eliminating the reset. So 5 interrupt, I am discussing how this interrupt will be working and how interrupt is occurred. How interrupt will be enabled and how priorities. These are the steps. These are the steps. If I'm talking about if any interrupt is working, so how work. So I am doing a program. So just assuming my total day work is nothing but a program. Whenever any particular person is exit, again come for the entry, means one kind of interrupt is generated. Means I stop my teach. Whenever I teach, then I just see who is coming. I just again admit him, then admit her, then again coming into the topic where I left. So in a main program, maybe one interrupt is coming. The next instruction to be executed, the address are stored into the stack. First execute the interrupt program. Means for interrupt, what are the requirement? Maybe some, whenever someone is sending a message, this is a very good interrupt. I like it. So whenever any message is coming, I just see whether he asking any questions or not. If asking is relevant questions, whatever I discuss, so I will be explain. Then I'm coming into the next topic. So it's nothing but just like an interrupt. An interrupt is coming in anywhere. Whenever I am in a program, I will be execute the next line. Before I execute the next line, I execute the first program of interrupt, then coming into the main program. This is the nothing but a steps where I all are written. And remember that RETI of the last line of the instruction, that is the return from the interrupt subroutine. And every interrupt, that a particular location is there. Every interrupt, there is a particular location is there. Sir, if I am asking you, just to give an example, if I am asking you, what is the independence year of India? Independence year of India? Anyone? Independence year of India? It's a very silly question.
1947, sir.
1947. Very good. 1947. How you give the answer? So whenever I given an interrupt, your brain, there is a memory location where is written 1947. So you are doing a program. So you are writing something. Whenever I asking, I just given just like an interrupt. You execute that particular program, and if the output, whatever whatever the output is coming, you are saying that output means we are executing this program, then you are coming again in your main program. That is nothing but an interrupt. So every interrupt have a particular locations. Say maybe you going into the correct locations, may not be I am going into the correct locations. Say I am given 1950. So 1950 is another event, maybe this there. So but whenever my pointer is working, maybe up and down it will be going into the 1950. So I am saying 1950. So like that. So every interrupt have a location. So this location is called vector locations. So in this in 8051, several locations is there. Those are just like 1947. Wow, many persons is given the answer. Thank you. So these are the 6 interrupt. Remember, one is the reset interrupt, another is a 2 interrupt is a called timer interrupt, 2 timer interrupt, 2 interrupt from timer, 2 interrupt for external interrupt, whatever INT 0 and INT 1, and 1 is a serial communication interrupt. So total is a 6 interrupt. If you are eliminating reset, so 2 plus 2 plus 1, that is a 5 interrupt. Every interrupt, just see there is a location 000B, 001B, 0003, 0013, and 0023, and 0000 reset. So every interrupt have a different locations. Whenever any interrupt is coming, corresponding program counter will be set this kind of value. 0003, 0013, 0023, 0000, etc. So this is the IE interrupt enable register. IE and IP is the most simplest things in the rest of the SFR register. Remember, EA is just like your main switch. In your house there is a main switch. If you are off the main switch, there is a other switch will not be work. Same thing like that EA. If EA is 0, then these bit all are nothing but a not checked. All are ignore means all the interrupt will be disabled. All the interrupt will be disabled, or all the interrupt will be maskable, you can say. Whenever this bit is 1 and this bit corresponding bit will be 1, then corresponding interrupt will be enable or disable. How interrupt will be enable? Say this is a 1. So if sir this bit is not 1, if this bit is 1, then this if this bit is 1, then the other bits will be checked. If this bit is not 1, then other bit will not be checked. Other bits will not be checked. How the other bits will be checked, sir? I just give an example. Say EX0, just just follow EX0, E for E for enable, interrupt enable. That's why E for enable. It's enable all. So enable X0. X0 means external interrupt 0. Enable T0 is for timer interrupt 0. Enable external interrupt 1. Enable timer 1 interrupt, enable serial communication interrupt, enable serial communication interrupt, enable serial communication interrupt, and ET2 is nothing but a timer 2 interrupt. ET2 is nothing but a timer 2 interrupt. So what are the functions of timer 2 interrupt? Sir, actually basically timer 2 interrupt is nothing but a not used in 8051, it will be used in 8052. But I am explained over here, it is not used in 8051, it will be used in 8052. So if say this bit is 1 and this bit is 1, and this bit is 1, so what will be happen? Only external interrupt 0 and timer interrupt 0 will be enabled. Rest, if this bit is 0, if this bit is 0, if this bit is 0, and these two as I ignore, so these two also 0. So what will be happen, sir? Only external interrupt 0 and timer interrupt 1 will be enabled. Rest all the interrupt will be disabled. Rest all the interrupt will be disabled. Right? Rest all the interrupt will be disabled. That is the function of IE. That is the function of IE. And remember the by default priority level. It is a very important thing. Remember the by default priority level. By default priority level means in this class, maybe some the persons are coming from the PM, some the persons may be coming from the CM reference. So I will be give the highest priority on them. So basically, depend upon the priority will be set. Priority 1, priority 2, priority 3 means in your class maybe you have some favorite students. So you will be given some soft corner on them. Means you are given sometimes whenever every person will be asking a questions, but you were given particular students question answer first, then you given to the another. So this is just like a priority. So by default priority level, external interrupt 0 will be the highest priority in by default. Then timer interrupt 0 will be the second highest. Third highest is external interrupt 1, fourth timer interrupt 1, and the next serial communication interrupt. These are the 5 by default priority level. With the help of this bit, you also able to understand, able to remember that the by default priority level from this side, from that side, external interrupt 0, timer interrupt 0, external interrupt 1, timer interrupt 1, and serial communication interrupt. So highest priority in by default external interrupt 0, and highest priority, lowest priority, that is a serial communication interrupt. And next is nothing but these are the vector locations which I already discussed. These are the vector locations. Okay, next, going into the level trigger interrupt. When the high to low interrupt, I already talking about, that is the IT0 or IT1, then interrupt will be generated. Similarly, if falling, it is the falling edge. If low level, then it is a low level. This is two problem, and these are the serial communications problem. These are the interrupt priority. Priority means say sir, these are the similarly priority external interrupt 0, same bits, only A is not there, only PA is not there. If remember IE, so IP is the same, there is a no change. IP is no change. IP is no change. So how IP is working? So PX0, PT0, PX1, PT1 serial communication interrupt. So if if this bit is 1 and if this bit is 1, sir, what are the by default priority level? By default external interrupt 0 will be the highest priority. By default external interrupt 0 will be the highest priority. But as this 2 bit is 1, but in in these 2 bit, which one is the highest in by default? So that is the external interrupt 1. So here the priority level of the interrupt, if the value of IP like that, rest all the bit is 0, then external interrupt 1 will be the highest priority, then timer 1 interrupt, then external interrupt 0, then timer 0 interrupt, then serial communication interrupt. So first highest priority will be the external interrupt 1, then then timer interrupt 1, then external interrupt 0, then timer interrupt 0, then the serial communication interrupt. This is the by default priority level. 1 is the highest priority. If I'm putting 1, then it will be the highest priority. But remember, if 2 or 3 1, then it will be working. If, among them is not just like a by default priority level. But if you are given only 1 1, then it will be the highest priority. Rest all are in a by default mode, nothing else. If sir all are 1 1 1 1 1 1, then nothing but it will be also a by default priority mode. Then nothing but it's also a by default priority mode. And next we are interfacing, which will be discussed tomorrow. And if you have any kind of questions, you can ask. We're coming the end of the session, so if you have any kind of questions, so you can ask. Otherwise, will be end of the today's sessions. Tomorrow we will be discuss the interfacings, and we will be discuss how some project will be implemented.
Thank you, sir.
Thank you, ma'am. Any queries if you have, you can ask. Okay, sir. Sir and madam, everyone, be safe. One last line of my everyday sessions. Now I cannot say the other things. You go outside, you enjoy your day. I cannot say. I say only one thing: stay at home, be safe. Nothing else. So it's a very bad language you can say, but in the present situations I cannot say rather than that. So thanks to everyone present up to end of the sessions. And if anything if you don't want to know, so I just end up today's sessions. I will see tomorrow again same time, that is a 4 o'clock. Thank you everyone. Thank you.